Assalamu alaikum, it's Saad Usman, and I have like more than 3 years of experience in the safety field. And I'm not just a safety officer; I am the in charge of health and safety. Means I am the head of department in our works, which is a best way cement. And moreover, I am like assistant professor in a fast university. Also, I have more than 3 years of experience in providing training. I am the trainer of OSHA and OSHA as well. So this training is all about the OSHA, and we have discussed the different standards, and this lecture is going to be in English, which and inshallah I will make it in Urdu as well. We will discuss the very basic standards, and this lecture is complete on very basic study. If you're interested, you can continue, and later inshallah we will also discuss the core concepts of the OSHA and the safety in other videos as well. Okay, so let's begin with the manual handling. And what is manual handling? Manual handling is basically any pushing, pulling, lifting of weight. Like there is some weight and I'm pushing it, pulling it, or lifting it. That can be considered in the manual handling, and it can be done via two things. What are the two things? It can be done through the manpower. Like if I'm lifting any weight, that will be considered in the manual handling. And if it's if I'm using any machine like the forklift truck in this, or any crane, which you can see, if you're lifting any weight from them, then it will be considered in the manual handling. Okay, so let's suppose if it's manual handling, if it's a person is involved in the lifting, then what will we will check? We have to guide them on the proper posture. The first thing is we have to eliminate that. We will discuss the hierarchy of control. But when it's not possible for us, what we do, we go to other controls. Inshallah, we will discuss in another lecture what are the hierarchy of control. So for this, if a person is involved in any lifting, then what we will consider that and how he is lifting, what is the posture, if he is maintaining any posture or not. We have two pictures. In this picture, you can see all the weight is coming to the person's lower back, which can hurt his lower lumbars, as we may have discussed that people do have injury on their lower back. That will be considered a hazard. So that's why we have to guide them how to properly maintain their posture. In second picture, what we see, that person is putting all the weight on his legs, in the leg muscles. He's not putting most of the weight on the back. He's just putting little of the weight on his back, and more of the weight is on his legs, because the legs muscles are the most stronger. And if they get injured, like if the leg muscle get injured, it will not affect the whole body. But if your lower backs get affected, then it will affect the complete body. So that's one thing. Okay, what will be the other controls? Providing the proper PPEs like the cotton gloves, or like the shoes, the safety shoes and the helmet, that are must. But for lifting, providing the proper gloves, cotton gloves for the good grip, that will be considered in the good control. Other things like providing which can help them carry a weight. If there is any trolley, that will be considered in a good control. What else can be there? Providing them the belt for their lumbar, the support, so they don't get injured. That will be also be a good control for that. Now, what if a person is not involved and there is machine involved? What will be their hazards? Let's suppose we have an FLT truck. What is a FLT truck? A forklift truck. Why we call it a forklift truck? Fork, we may have seen fork. These two, like you can see the teeth in front of it, that are the forks. In English, we call them the forks. That's why it's known as the forklift truck. So for that, for the forklift truck, the physical inspection is very important. You have to maintain a checklist for that. Industry do have a checklist for that. And for after completely inspection, what will be inside the inspection? The physical condition of that, and the tire condition, the cabin condition, and what else? The driver, if he is a proper license, he is a proper third party certified. He knows how to properly drive a forklift truck or not? Okay. And what is the maximum capacity of that FLT? And you will never reach the maximum capacity. You may know about the SWL, which is a safe working load. Okay. Also, more things you have to check: how much the weight is carrying and what is the height of the weight. Like, let's suppose if the height of, let me, if this is the height of it, okay, and this is me sitting, well, I don't have a license, but still we are just assuming I am the driver, and what will happen, nothing is visible in anything in front of that weight. Okay, I cannot see what is in front of that weight. If there is any person standing and he's not like aware that I'm driving forklift truck and he can hit me, so what will happen, an accident can happen. So that's why what we have to consider, that for such act, sorry, let me erase it first. We have to carry weight at such height so that the sight is visible to that person. Other things, the backlight must be available. Okay, the reverse light must be available. The reverse mirror must be available inside the cabin. Okay, so he can see on the back. Also, there should be a beeping sound. Like when we do the reverse, there's a beep sound, beep beep. Okay, so that sound should be available in such heavy machineries, so that person standing behind must know that that the FLT truck is reversing. Let's suppose if there is a continuous activity, so the area of fire should be defined. Also, there must be a backsman available. Who is a backsman? A person who guides the FLT driver that you should go right, you should go left. The person who is signaling him, that person must be available. So that's a few of the controls which we can apply to such activity. I hope it's clear. Okay, we will go to the crane. So for crane, there's also a physical inspection for that. In our works, we do not allow any crane before the inspection. Two of the teams are involved. One is from the mechanical team. The mechanical team person will check everything and he have an inspection report for that. He ticks and crosses everything, like if the person or the dry operator have the third party and the license or as well or not. Also, the physical condition of the crane, the load capacity, the safe working load chart is mentioned or not, the hoist, the slings of it. We will have a different lecture for everything of crane as well, but here we will discuss about the standards. Okay, and once the crane is entered in your works and it's moving and it's going for any activity, they will again check the boom of it. They will make a scenario that the crane is involved in activity, and they will check every part of it, that the outriggers, the boom of it. So what is the reason for that? So that they can ensure that everything is in working condition and there is no leakages. The most important thing is there should be no leakage on a crane. Okay, on the hydraulic pump of the crane. Also, while the crane is working, you should know that what is the distance between from the overhead power lines and the crane. So for now, there will be another video I will have attached, which is with my students. So you should continue from that. Thank you. Okay, I got one answer, which is 5 meter, and I was asking how much should be distance from your equipment, your crane, and the overhead power lines, which we cannot define like this. There's no such standard exactly defined that you should keep or you should maintain the distance from every wire. It should be like that we are assuming it should be 5 meter or 10 meters. There is not such exact figures. What we have to consider first, we have to consider the voltage of that wire, how high the voltage is. Let's suppose if it's of 132 kV. So you should maintain 15 feet. Okay. And if it's less than that, like if it's like 120 kV, then the distance of should also be minimum. Okay, the distance should be less. Do you understand my point? That the distance depends on the voltage or the how much high voltage is passing through that wire. If it's of 20 watt, then you have to maintain less distance. If it's of 132 kV, then you have to maintain more distance because there's an electrical range. Okay, you have to keep your equipment far from it.
Mr. Saad, I think someone in waiting room or something try to attend.
Some is in waiting room, but are all allowed. I have allowed everyone. There is no such request on my Zoom meeting because everyone is allowed to meet. Okay, so you have to check the load chart in the cab, the safe working load chart. Okay. Frequently inspection, like first inspection you have done when the crane enters your workplace, then before the work starts in your workplace, then after every shift, during the shift, because there may be some sort of leakages which you have to identify timely. Never lift people. Check overhead power lines, ensure area of travel is clear, like you have to barricade the area and you have to maintain the distance. And let's discuss that how much should the distance should be maintained. Like this is the crane. Then how much the distance should be maintained? How far I should stand? So it depends on the radius, okay? You cannot stand on the radius of that crane. That's the safe zone where I can stand. Understood? So there's a term ergonomics which comes in the manual handling or uh, mostly for the workers who are working in offices. What is ergonomics? Ergonomics tells us that the equipment provided to the worker should fit for it, and it does not contain any, and it does not like contain any hazard. It should be fit for it, and the worker should not forced to be fit for that equipment. That's some short definition for the ergonomics. Let's suppose if I'm having a chair, I'm sitting on chair for more than 8 hours a day. So the chair should be according to the ergonomics, the length of it, the comfort level, their handles, for my arms rest. The desk which I've given should be according to the ergonomics, like the length of it. The screen on the laptop I'm keeping, it should be aligned to my eyes. So that's are the few things which are considered in the ergonomics. And it should also be considered, and we also discussed this in the NIBOSH and IOSH as well. Because if you do not follow such ergonomics, what will happen? You will have the MSDs, the musculoskeletal disorders. So that's the reason we do discuss this in the manual handling as well. So, so now we will discuss the hand and power tool safety. What are the tools of for hand tools and what are the power tools? So difference is the tools in which you use your own force, like the man force. Like you have the cutter, you have the screwdriver, and you have a hammer. These are considered in the hand tools which you would use daily at your homes as well, and these are daily use in the workplace. What are the power tools? Power tools are the tools which get some power, like some sort of energy. Like it can be a battery operated, it can be the electrical operator, it can be pneumatic, the air pressure. So that are the considered the power tools. What are the hazards if you are using manual, sorry, the hand tools? So if there's any insulation, like the insulation, it should be proper and there should be no cut. Or if you are working in electrical equipment, you may get electrocuted. What other? It should be always sharp, and whenever you whenever you use them. try to keep them in their own place. Do not just throw them on the way, because in case of an emergency, a person may fall from them. Now, if we talk about the power tools, no, for power tools, let's suppose the example is the welding, the welding machine. Okay, so what are the hazards which are opposing from there? The welding plant, the connection from where you are getting that electrical connection. If it's not properly connected, you may be using like your own techniques to connect that. That can be, let's suppose we have this welding and cutting. Other thing, the wire, the cord, if it's not properly insulated, that can be a hazard. You get electrocuted. If it's not properly earthing, the earthing is not done, or there is no grounding done, that can be hazardous, or you can get electrocuted. The other things can consider the heat coming from while we are doing the welding. That's also a hazard. So every power tool and every hand tool oppose their own hazards. So you have to do the proper inspection of them. There should be inspection record maintained. Inspection must be done prior to the work job. If you find any equipment faulty, you have to report it. Do not use it and do not alter it. Do not remove the safety guards from it. If there is a safety guard available on equipment, do not try to remove that. Okay, what are the hazards? Objects that fall, fly, or aggressive or splash, harmful dust, fuse, misses, vapors, and gases, frayed or damaged electrical cords, hazardous connections, and improper grounding. That are the some like few hazards of the hand and power tools. There may be more. Use PPE such as goggles, safety goggles, and gloves. Keep floor surface where working from tripping and slipping hazard. Keep cutting tool sharp. Why they have written keep cutting tool sharp? Like if I give you an example, you are trying to cut some meat, okay, and the knife you're using is not properly sharp. So what will happen? You will try to add more force, and as you will add your more force, what will happen? You will cut yourself if it gets slipped. So that's why they have mentioned always keep your tool sharp, so you do not apply more force to it. Okay, welding and cutting. Here we will discuss the arc cutting and the welding. Few of the hazards I've already discussed, and I want you to understand and to observe what are the hazards in this picture. Can anyone tell me what are the hazards in the welding activity? And as you can see from in the picture,
The spark
okay,
and the light.
okay, yes, the highlight, helium light.
Yeah.
More, yes, the smoke. I just got the answer in the messages. What else can be there?
Hot surface also.
Yeah, hot service. So yes, as you have all mentioned, there are multiple hazards in this picture and the welding plant, okay, in the welding activity. So if there's a welding activity, I have told you that if it's not properly, earthing is not done or the grounding is not done. Well, for the welding plant, it's mostly earthing. If it's not properly done, that is also a hazard. If it's not properly connected, that is also a hazard. If the wire is damaged, that is also a hazard. Now, if it look at this picture, you will see in the room there is no proper light, and the welding there is a highlight, so that's also considered hazard. The spark coming from it, the heat coming from it, the fumes and dust coming from it, that's also considered a hazard. Also, few more things which you have to consider. If the worker is not competent enough, he don't have the right knowledge, the right experience, the right uh, expertise, then we will consider that it's also a hazard. Other thing, where he's performing the activity, welding activity. Like if it's a oil drum, if there's any gas in that drum, if there's other material in that drum, he may damage that, and he may like it may get fall into result into the explosion. So that's some of the hazards of the welding. Fire, explosion, material damage, electrical shock, fumes, gases, leakages, and incompetency of staff is also a hazard. Supervision must be provided if there is some sort of critical activity being going on. If there is an arc welding where cylinders are being used, so we have the acetylene cylinder and we have the oxygen cylinder. According to OSHA, do not keep both of the cylinders together. Maintain distance of almost like uh, 10 to 50, 20 feet. There's some figure which I don't remember, but it's 10 to 20 feet of uh, that you have to maintain the distance from the acetylene, the fuel, and the oxygen, which helps the fire. You have to mark the cylinders. You have to keep them like if you have cylinders, like this is cylinders. You have to chain them so they do not fall on the ground. Must be safety caps available on cylinders if they are not used and if they are being transported from one place to another. There should be a different and a separate vehicle for it. They should never be laying down, okay? And there must be marking on it what kind of cylinder is there. If there's O2, if O2 should be mentioned. If there's CO2, it's CO2 be mentioned. If it's of acetylene, it should be mentioned. Soap testing, if you may have heard about the soap testing must be done. If there's any leakage, the soap testing should be done. If anyone of you about the LEL and the UEL limits, and if you don't, please let me know so I can explain. It's not the part of this training, but if I just want you to add into your knowledge. Do you have any idea about the LEN and UEL? Anyone? Should I continue or should I explain the LEL and UEL? Okay, I will continue. Okay, I will explain. Okay, I just got some few messages. It's very important for the understanding. This is the LEL, lower explosive limit, and this is the UEL, the upper explosive limit. The LEL and the UEL of the gas cylinders which we use normally in our rooms and in our houses, sorry, that's of like the level is of 2 to 8 and 10% in the air. So that's what the lower explosive limit and the upper explosive limit is. It is. If it's less than that, no explosion will happen, and it's more than that, no explosion will happen. Okay, are you understanding? Just say yes or no in the message. You can. Those who cannot talk. If it's lower than that, the explosion will not occur, and if it's more than that, the explosion will not occur. Now let's suppose there is a leakage in the room, and that's a confined space. Like there's a room. Okay, it's become confined due to the leakage and the limitation of it, and there's all gas. But the limit of the gas is in the more than UEL. So the explosion will happen or not? Can anyone answer?
Again, please, again.
Okay. There's a gas leakage in the room and the door is closed. And the limit of the gas is in more than UEL, the upper explosive limit. The explosion will occur or not? If the oxygen level is okay and if there is any source of ignition.
I think not. They will not explode.
The reason is why? Because it exceeds
They
from
will,
the UL.
yeah.
Yeah, it exceeds from the UL. Now let's suppose I open the door. Now what will happen?
When you open the door, they will add more oxygen, so it will explode.
Yeah, it will come into inside this limit. It will come inside this limit. The oxygen will be more provided, and the upper it will come from the upper to inside the limit. Now there is a chances of the explosion, high chances. So whenever there is some sort of condition, you have to understand few things that explosion can occur. First thing. Secondly, if the lights are on or the lights are off, if the fan is on or the fan is off, any button, any electrical equipment, if there is in on state or off state, never try to change them. Understand? Because when you try to on a button, let's suppose this is a button, and that's the off button. What will happen? The wires behind them will attach and they will create an arc. And that will be the source of ignition, which we discussed in the fire triangle. The O2, the fuel, which is this leakage of gas, and third is, which was missing, that's the arc. So you have to consider these things, okay? I hope this was informative for you. If you have any question from this, you may ask. Okay. Special risk assessment required separate storage places. You have to keep them, barricade them in different places, which is in engineering control. Inshallah, if we have any chance in future to study the IOSH, we will discuss this and that. What's the risk assessment and what is the engineering control and everything. Clearly marked tags, they should be mentioned. It's of oxygen or something. Separate vehicles for the transportation. Do not like move or do not transport cylinders or any source of ignition or something. Oxygen cylinders in the same vehicle. Training instruction information should be given, should be provided to the workers, and clearly insulated wires. So the wires should be also be insulated. They have mixed the like the welding and the gas cylinders. Okay, so now electrical safety. What is electricity? The flow of electrons. We do know that, and there's some flow of electrons inside our body, which is we do require for our normal function. But if it exceeds, then it can be a fatal. If the shock you absorb is more than 15 ampere, that can consider in the fatal or fatal electric current. If it's lower than that, you may feel pain. The time also depends on how long you do expose to the that current. But if it's for the short time and you do expose to the less than 15 ampere, then that is safe. That's not fatal, but it will hurt you. If it's more than 30 ampere and so on, that will be considered in the fatal. Like you will lose a life due to that. We have a be safe method, which is burns. Like what will happen from the electricity, electric shock. You get burns, electrocution, that the fatal exposure to electricity. If a person dies or the potential of that shock was that can kill a person, then we say that's electrocution, the term we use for the electrocution. Shock have two things, which is the direct shocks and direct contact and the indirect contact. When a person contact with the live parts or conductor that is supposed to be live, then that will be considered in the direct contact. And if the person come into contact with the conductor that is not supposed to be live in normal conditions, like you were thinking that there should be no electricity in that equipment, but you get electrocution or you get the electric shock due to some fault. Like there was some sort of shortage or some sort of like fault in that equipment, and you get the electric shock, that will be considered in the indirect contact. Arcing is one of the hazard. The electrical connection which is made in the air, and you see in the air, that connection is known as the arcing. Fire can happen and explosions can happen. So we never keep such cylinders or flammable material near electrical equipments. Even if in my industry, where they are storing the barrels of the oil, there is no light in there. No light. If they need light, they uses the torches. How you can control it? By using the fuses, circuit breakers, earthing. Earthing is technique which I've discussed before. Isolation, that's the very important part which we will discuss inshallah in the very last. The low toto, you may have heard about it. Reduce voltage, battery operated tools, and double insulation. Okay, you may have heard about the ELCB breakers, earth leakage circuit breaker. These are very like safe for the people. They get break if there's a minor leakage in the house or in the water or something. So if you do not know about it, you may search about it, and you should consider them in your houses as well. Okay, the fall protection. That's also very important thing, and that's a very normal activity in every industry. The work at height. What is work at height, and what's the hazard from it, and what's the risk of it? That's the fall. Work at height is itself a hazard, and the risk from the work at height is the fall. You get fall, you injures yourself. That will be considered the risk. So what is fall? When you come to the surface of Earth from a certain height and get injured, and that fall is unintentionally, then it will be considered in the fall. And when does the fall happen? When you are working in a height. And what's the standard for the work at height in most of industries? And what we do study in the construction side is 1.8 meters in the construction side, and general industry it's 1.5 meters. And 1.8 meters is approximately 6 feet. Like it's like 5.9 and something figure, which we count in the 6 feet. If you're working 6 feet or more than that, then you will have to consider few of the safety things like which we will discuss right now. And where can the fall can happen in industry? The scaffold, ladders, roofs, and other elevated work surfaces. How do you protect a worker? You can protect them by the guardrail system, by personal fall risk system, safety net system, positioning device system, warning line system, safety monitoring system, and the control access zones. We will discuss them one by one. What is the guardrail? You may have seen beside the stairs, and you may have seen in the we do make them on the scaffolds and on the elevated areas. These are the guardrails. What is the standard? The length should be from bottom to the top. It should be of 42 plus minus 3. Like it can be 45 or it can be 39 inches. It depends on the situation, like which is feasible. The width of the guardrail should be 2 inches or more. How much force should bear? The 200 lbs or 200 pounds of force it should withstand. There must be mid rail available between the toe board and the top rail, and the mid rail should be installed halfway between the top rail and the work surface. The second, we have the safety net system, and let me draw a building. Let's suppose this is a building, and that's the top floor where workers are working. And here there's a possibility that the worker may fall and get injured, and that's the second last floor. Here we will install the safety net system. Okay, that's the nearest part to the fall where a fall can happen. That's the best place to install the safety net system. But how do we test the safety net system? What we do, instead of throwing a man, what we do, we take a sack, okay, of 400 lbs, and we throw it from that height from where a fall can happen. If this safety net withstand that, right? So if it withstands that, then we say that yeah, that safety net is according to the standard and as per requirement. Try not to throw any person, okay, for testing. A warning line system. What is a warning line system? It's a wire and there are some flags on it, and the distance from the wire and the area from which a person can fall should be of 6 feet, and the distance between the flag from one flag to another flag should be of also of the 6 feet. And how much weight this wire should withstand? It should withstand of the weight of the 16-pound force. There are some few missing, like which we'll discuss as a personal fall arrest system. You may have heard about the SRL, self-retractable lifeline. That's how the SRL looks like. You connect on the top. There's a wire inside it, sorry, and you connect it to your harness. Here you connect yourself to the harness. Like if I'm moving slowly and in a right angle, like to the top, it will slowly move with me. But if I fall due to some unconscious or if I get slip and the angle changes, it works like a seat belt, the seat belt in a car. And if the angle changes, it will not allow me to fall. It will stuck on that position, on that position. That's how the SRL works. The warning is okay. So the safety monitoring system and the control access zone. What we have in this, we have the cameras and AI tools as well. If this person is standing on an unsafe place, what they do, they identify that, they mark the person red and allows you to talk to that person and warn them to move from that place. That's how that works. Okay. So excavation. What is an excavation? A man-made cut, cavity, trench, or depression formed by the earth removal. If you remove a part of surface of the earth, that will be considered in the excavation. And what will be a trench? But this is a trench is a narrow excavation. The depth is greater than the width, but not wider than 15 feet. This is the how a trench looks like. You may have seen we do make for installing pipes and something. We do make some trenches. That's a trench. If the excavation is 5 feet deep or more, when we will say that excavation is deeper, when it's more than 5 feet. Primitive systems are required unless it's made entirely on the stable rock. There are some four types of soil, and one is the stable rock, the second is type A, type B, and type C types of soil. And we have how we will control them. We do have their controls as well. What are the hazards and the greatest risk in excavation? Asphyxiation, maybe you are going underground or you are going in a tunnel. So there's maybe a lack of oxygen which will can cause the suffocation or the asphyxiation. Inhalation of the toxic material, there can be some toxic gases. Moving machinery near the edge of the excavation can cause a collapse. Like if you are standing or to the edge of it, or there's a machine on the edge of it, it will start collapsing. So how much the distance should be maintained? The distance should be maintained of the 2 feet. Okay. Okay. What are the techniques to save a collapse or the cave-ins? Cave-ins is a collapse of the soil. Yes, Abdullah Al-Raqqa, they answered the ground might collapse and the someone could fall if they are nearby. That's the point which I was trying to explain. So how do you control that? By shielding, that's a technique. Shoring is a technique, and the sloping. What is sloping? Let's see that. I think there's a picture on it as well. I just show you. That's the sloping technique, okay? But the thing is, why do we have so many techniques when the sloping technique can be used in every type of soil? The thing is, and we have to understand that the area which is this technique is taking is a lot. So maybe it's not possible everywhere to make such uh, large or consume large area for using this technique. If you are going inside, like you are making a excavation of 1 feet, then how much the slope should be made of 1.5 meters. You have to keep off the 1.5 meters. If it's you are going 10 feet, then it will multiply and form to 1.5 meters. Oh, sorry, feet. So how much it will be? It will be some 15 feet, okay? You will go down 10 feet, you have to keep the distance of you have to make the slope of 15 feet. So, but that's why it's not possible everywhere, but it's the most suitable thing and the most good thing, good technique to use, but it's not possible everywhere. That's why we have some other techniques as well. What are the other techniques? The shielding. What we do in the shielding, if you are making a excavation like this, so what we will do, we will keep a steel made of metal inside it, and there will be stairs like made in it as well as these are the part of this shielding. And there's strong structure. This is a very strong structure which supports and which holds the soil. So the soil cannot collapse here. Okay. Shoring also like shielding, but the thing is here we use the scaffold pipes. Like this is excavation. What we will do, we will install the scaffolding pipes here and we will install many scaffolds to hold the soil. And that's also a technique. What should be done before excavation? Evaluation soil conditions. You must know about the soil conditions and you must have the blueprints. Maybe there can be or there may be some sort of electrical pipes or electrical cords under the soil. There may be water pipes, sewerages, or some utility facilities inside that. So you have to consider them. And in America, as per OSHA requirement, you have 24 hours to call the 811 number. And what they do, there's a utility team, they help you to identify what are the if there's any underground piping or something. And if they cannot help you in 24 hours, then you are allowed to do the excavation. You can allowed to start the excavation. And when you start the excavation, if you find any pipe, you have to consider them and you have to control them and you have to mention them and save them so you don't no one can gets injured from that. Construct protective system as we discussed these shoring, sloping, and all the techniques. Test for the low oxygen, hazardous fumes, and toxic gases. I just did it this in the very morning. There's some sewerage which we are trying to clear, and the gas testing should be performed there. The gas testing, there's a device which tells about the oxygen level, tells about the carbon monoxide, the H2S gas, and the carbon dioxide. It tells you the level of it. If it's any availability of some toxic gas or there is low level of oxygen gas, it identifies it, start beeping. Provide safe in and out access. Contact the utilities, determine the safety equipment which is needed. What other things should be considered? Traffic, proximity and physical condition, nearby structures, soil classification, surface out and the groundwater. If there's some, if you think there can be leakages in the groundwater or it can fill the excavation, you should consider them as well. Location of the, yes, before digging, make sure you are not digging over an electrical cable so you don't cut it and make a problem. Yes, Abdullah. Overhead and underground utilities, weather conditions, quantity of shoring and protective system that may be required, fall protection needs, number of ladders that may be needed, and other equipment which are required. You should consider them before making the excavation. That's the normal range of oxygen in which we breathe. That's the 19.5% to 23.5%. If it decreases from 19.5%, we do feel suffocation. If it get more, we have some medical conditions in it as well, and the uh, high chances of fire or explosion. There are some toxic gases, which are hydrogen sulfide, H2S, commonly known as H2S. If it's in the 20 ppm, that's the ceiling limit of it. More than that can be toxic. ppm means particles per million. Carbon monoxide is 50 ppm, and the time weight average is defined of 8 hours. TW8, the time weight average. Methane gas, flammable or explosive, no specific OSHA PL, but has the lower explosive limit. And the ammonia, corrosive to skin, eye, lungs, 50 ppm, the time weight average, and how long the worker can work in such condition. If it's 50 ppm, then that's 8 hours. Okay. And the chlorine is very toxic, highly toxic respiratory irritant, and the ceiling limit is of 1 ppm. If there is an one particle per million, then that's the limit. You cannot cross or you cannot work in that condition. What you say, enough for today?